Hi guys, in this episode of Shri series, we're going to be practicing more questions on how to balance net ionic equations, alright? So if you looked at my previous video, I had two examples of how we balanced net ionic equations. We used an acid, for example, acid-base reaction. I gave some examples, and then we looked at the process by which we balance the net ionic equation. All right, so today we're going to look at two other examples of different reaction types. So the more we get different types of reactions, the better are our opportunities to score higher marks when we get types of questions on balancing net ionic equations. All right, so if you remember the basics of getting full marks when we are told to work out the net ionic equation, you got to remember your valencies, all right? Like I mentioned before, by that I mean you need to know the correct cations and anions, all right? You also need to know your chemical formulas of the compounds taking part in a reaction, whether it's the reactants as well as the products, all right? You also need to know your balancing of equations, all right? So it's very important that you guys learn the above three, because when I'm explaining or going through net ionic equations, I go with the assumptions that you guys know how to go through these three components. All right, so with that in mind, let's look at a simple example of what we refer to a double displacement reaction or a precipitation reaction. So I'm not going to explain what these reactions are, but I'm going to give an example of these reactions and then show you how to balance the net ionic equation, all right, and also go through the stages through which we can get to your answer. All right, so with that in mind, let's look at a simple example. All right, like I said, I'm going to go through the word formulas, word equation, and then we go through the chemical equations. All right, so let's look at lead. All right, lead to nitrate. All right, reacting with, let's say, for instance, potassium iodide. All right, so obviously this is the word equation, and we know very well when they react, they form these two products, which is lead, or should I say, lead to iodide and potassium nitrate. All right. Now, if all equations required you to use the word equation, I think most of us would get full marks. However, in chemistry, we need to write down the chemical equations. I mean, in other words, use the chemical formulas. We need to balance and also write it down to the net ionic equation. So this will be how the word equation would be. Lead to nitrate reacts with potassium iodide to produce lead to iodide and potassium nitrate. All right. Now, how do we work through the chemical equation? All right, like I said, I'm not here to talk to you how to write down the chemical formula, because I go with the assumption you guys know. All right, so how do we write down lead to nitrate? All right, so that's going to be PbNO3 Now you need to understand solubility rules. All right, so the general rule of thumb is that all nitrates are soluble. All right, so they dissolve in water, so that becomes aqueous. So lead to nitrate reacts with potassium iodide. So we know very well that's Ki. That's also aqueous. It dissolves in water. And it produces a yellow precipitate. And a precipitate, as you guys know, is solid as a state symbol. So you're going to get PbI2, and that's solid, and reacts to form another aqueous solution, which is potassium nitrate. That is KNO3 aqueous. All right, so you can see here I've written down the chemical formulas because I've got experience working through these cations and anions and know how to combine. All right, so lead to nitrate is aqueous because all nitrates are soluble, reacts with potassium iodide, which is also aqueous, to produce lead iodide, which is a yellow precipitate. So hence the state symbol is S. under potassium iodide, and it produces another aqueous substance called potassium nitrate. Okay, so we've got the right formulas, we've written the state symbol. Like I said in the previous video, you need to write down the correct state symbol. The next question I'm going to ask is my equation balanced? I can see that there's a 2 there, all right, but there's one iodine there. So let's say if I put a 2 there, what happens? I put 2K there, all right, so I'll end up having 2 potassiums. I've got 1 potassium. I'll put 2 there, all right? So my nitrates also balanced because I've got 2 nitrates on my left, 2 nitrates on my right, 1 lead on my left, 1 lead on my right, 2 potassiums left, 2 potassium rights, and therefore 2 iodines left and 2 iodines right. So therefore my equation is balanced, okay? Now, if you remember the rule of thumb, when we want to balance net ionic equations, we look at the aqueous substance. All right, we split the aqueous substance. All right, so you can, if you want, circle the aqueous substances. So in that way, you know which ones we're going to split. All right, now you don't necessarily need to do this in an exam. You won't have time. So I just wanted to show for those who are getting to know and understand this topic. All right, so if I were to balance this, which I already have, and I now need to split them up, and I will split PB, okay, use different color. So when I split that up, that's now going to be 2 PB2 plus and 2 NO3 minus. So like I said, you must remember, okay, in this situation, so I took the 2 out, you'll see that you need to split to lead and nitrate. So it's very important you know the appropriate valencies of your cation and your anion. If you don't know that nitrate's -1 and you put -2, you're going to get the equation wrong. So it's very, very important that you know the valencies of cations, anions, as well as polyanionic substances like nitrate. We split potassium iodide, so you can see, so that's 2K plus and 2I minus. Because what I'm saying is I've got 2 atoms of potassium and 2 atoms of iodine to produce PbI2. So PbI2 is a solid, so I don't split that up. And that becomes 2K plus and 2NO3 minus. So if you see carefully, there's a 2 there, so it's 2 potassium plus and 2 nitrate minus. So you can see in all of them, the valencies are correct because potassium's in group 1, so the valency is +1. Nitrate's -1, all right? The next thing we need to do is we need to look at the spectator ions, and in the previous video, spectator ions are ions that do not take part in a chemical reaction. They're not involved in a chemical reaction. As the word suggests, they merely spectate. All right, so we look at which ions are common both on my reactant side as well as my product side. So I can see I've got 2 NO3 minus and I've got 2 K plus there. So therefore, what remains in this case is PB2 plus 2I minus to produce PbI2. That's a solid, that's an aqueous, that's an aqueous. All right, and that now becomes my net ionic equation. All right, that becomes my net ionic equation. So you can see it's balanced. So the actual reaction taking place is lead reacts with iodine to produce the yellow precipitate, which is lead 2 iodide. All right, when you see this reaction, you'll actually see that both are colorless. So lead 2 nitrate and potassium iodide, you react them together, they are going to form lead 2 iodide, which is a yellow precipitate, and potassium nitrate. All right, so that splits up. So that's how we work on net ionic equations, particularly in this example, which is an example what we refer to as a precipitation reaction or a double displacement reaction. All right, now let's look at another example, because like I said, the more examples we do, especially with different reaction types, the better our confidence. So let's look at an acid carbonate reaction. So a simple formula for an acid carbonate reaction is an acid reacts with the carbonate to produce salt plus water plus carbon dioxide. All right, so all acid carbonate reactions yield three products, namely salt, water, and carbon dioxide. All right, so we'll give an example of an acid, an example of a carbonate, and then we will balance a net ionic equation. All right, so let's look at the carbonate, say sodium carbonate. Now, if you look at sodium carbonate, we know that's Na plus CO3 minus 2 minus, so that becomes Na 2CO3. All right, reacts with dilute hydrochloric acid, so let's say HCl. All right, now we know that is aqueous. All right, that is aqueous, and the salt it's going to produce is sodium chloride, so NaCl plus water plus carbon dioxide. All right, so that's going to be aqueous, that's going to be liquid, and that's going to be gas. All right, so is my equation balanced? I need to work out. Not quite yet, because we can see we've got two sodiums here and one sodium on my right. Suppose I put a 2 there. All right, what happens to my chlorine? So we've got an imbalance in chlorine. We now have two chlorines on my right, or the product side. We need to put 2 chlorine 2 right there. So that now balances my equation. I've got 2 atoms of sodium on my left, 2 atoms of sodium in my right. Carbonate balances. There's 3 oxygens, 2 hydrogens, 2 chlorines, and 2 fluorines. So my equation is fully balanced. The next thing I need to do is to split the aqueous solution. So I can always circle the aqueous just to show you what I'm going to be splitting. Great. So let's split sodium carbonate. So we've got 2 atoms of sodium, so that's going to be 2 Na plus CO3 2 minus, reacts to produce 2 H plus and 2 Cl minus to produce 2 Na plus, 2 Cl minus to produce H2O and CO2. All right, so we've now split all the 3 aqueous solutions. The next thing we need to do is work out which ones are the spectator ions. I can say 2 Na plus there, 2 Na plus there, 2 Cl minus there, 2 Cl minus there. So what remains is carbonate and hydrogen on my reactant side, and I've got water and carbon dioxide on my product side. So my net ionic equation therefore becomes CO3 2 minus plus 2H plus to produce H2O plus CO2. That's aqueous, that's my liquid, and that's my gas. All right, now if we looked at my first video talking about the balancing of net ionic equations part 1, I mentioned all acid-base reactions will have the same net ionic equation. This also follows with all acid-carbonate reactions. Whether you pick any acid and any carbonate together, combine them, you will get the same net ionic equation, which is right here. All right, so this is really an example of using different reaction types and balancing net ionic equations. They all have the same concept. It's really important, like I said before in the previous video, you need to know your valencies of cations and anions. You need to know your state symbols. You need to know how to balance equations, and all these combined together will help you or give you the skills required to solve net ionic equations. All right. Thanks for listening, guys. Bye now.